watching the Target 7.4 retest video. Make sure you have the white packet in front of you, and any extra help that you need before or after school with your teacher. You can also see them during advisement too, that works. All right, let's take a look at that first group of problems. I give the problems to you in factored form, and I ask you to find all the rational zeros. So this is just like factoring a quadratic expression from last trimester, or from last unit, from unit 5. When you have all the bundles, and we want to find the zeros, all that means is we're going to set each one of these equal to 0. Some of them are really easy to see. For example, this, x equals 0, and this one, x equals positive 1. I think some of us as students made the rule that it was always opposite, but we can't just say that with the 3x plus 1. So the two steps that you need to solve this are subtract 1 and divide by 3. And I end up with negative 1/3. So if you can get to the place where you can do that in your head, great. It's going to take 2 steps to get that, but it's not too tough. So if we take a look at number 4, you notice this one has a squared sign. All it means is that this piece happens twice. So really it's 2x plus 13 equals 0, x minus 1 equals 0, and there's another x minus 1 equals 0. These are a piece of cake. X equals 1, x equals 1. This one a little tougher again. Subtract 13 and divide by 2. So notice how that answer looks. Subtract 13, divide by 2. You end up with negative 13 halves. We get x equals 1 twice, and the way you'll see this in answer sheets, I think you'll see it in braces. Negative 13 over 2, and you'll see 1, that's the 0, and it'll say MULT 2. So explaining this a little bit, this just stands for multiplicity. Multiplicity just means that it happens more than once. In fact, this happens twice. Twice comes from here and there. Alright, so we have negative 13 halves and then 1 twice. Okay, that should get you through that first set of problems. The next set of problems here I'd like to go through with you together. It says, how many solutions does every cubic function have? We're going to write 3 there. Cubic, 3. It just matters what kind they are. So looking at number 8, 9, and 10, I give you a couple different possibilities. So this one goes through the x-axis 3 times. So there's 3 real solutions here. Those x-intercepts are also the solutions. And what are they? X equals 0, x equals 2, and x equals 3. And number 9 looks a little different. There's still going to be 3 solutions. In fact, since this one bounces off the x-axis, since it bounces off the x-axis, that means that that one has a multiplicity of 2. So this one also has 3 real solutions. And they are x equals negative 1 and x equals 2, and that actually happens twice. So I give a little leeway. You can write it twice if you wish. You can say, you could have said, instead of writing it twice, say 2 with a multiplicity of 2. That works too. Alright, then this last one, you see it only goes through the x-axis once. There's no bouncing, there's no other loop that goes over the x-axis. So we know that we have 1 real solution and 2 imaginary solutions. Okay, and the real solution is x equals 4. The imaginary solution would need an equation. We'd need to use the quadratic formula then to find the rest of it. So there you go. Feel free to rewind that and review that before you take your test. Let's look now. We're going to do 5 of these problems. I want to show you these first 2 together because one of them, number 11, number 15, one of them says 1 root's been given. The other one says 1 factor's been given. So the factor is kind of like the bundle, and we want the 0 to go into the box for synthetic division. So root is another word for 0. So this one's good. This negative 5 goes right in the box. But a factor, x plus 2, is like having a bundle, x plus 2. The 0 that goes with it is negative 2. That's the one that goes in the box. All right. Now remember, when you're setting up synthetic division to Use place value of 0 if you see any exponents missing. This one has x cubed squared first and a constant, so we're good here. 1, 1, negative 17, and 15. Looks like this one has a cubed squared first power and a constant, so this one's good too. But if we were missing any of those, we'd want to make sure that we put a 0 in its place. Alright, so the process for finding the rest of the zeros is using synthetic division. Do that first. And you should always get a 0 here, because that's what it says. This is a 0. If you don't get a 0 there, you probably did something wrong with either this piece or all the blue pieces. So x squared minus 4x plus 3 equals 0. Once we do synthetic division, now we're going to go ahead and use one of the three methods. Factor, we use square roots, or the quadratic formula. One of those three is going to work. Quadratic formula works every time. Factoring and square roots make your life easier. In this case, if we kind of test out factoring, we see that two numbers that multiply to be 3 and add to be negative 4. Negative 3 and negative 1, so that gives us two other solutions. Oops, it's positive 1 of 3, 1, and then on the back you'll also see the negative 5. If you want to write them like they do on the back, you would see in braces negative 5, 1, and 3. There you have it. Okay, the second problem that I have here is completely the same way. I must have done something wrong here. Since I didn't get a 0 here, something goofy must have happened in my work. So I'm going to take a look at my work. Oh yeah, right here. 0 times negative 2 doesn't give me negative 2. We see that a lot. Now I fell prey to it too. Negative 2 times 0 is 0. Multiply. Now we get the 0. So what do we have left? Remainder constant x to the first, x squared. I get 1x squared minus 4 equals 0. This one can easily be done using square roots. X squared equals 4. Take the square root of both sides. I get positive 2 and negative 2. So the answer is written negative 2, the multiplicity of 2, and positive 2. You can notice negative 2 is a multiplicity of 2 because it's written twice. Alright, let's move on to the next few. Now in these, we're not given a 0, we're not given a factor, we're not given anything. So we're going to call on our trusty calculator. So using a calculator, we're going to try to find, here's that first one plugged in, we're going to try to find one of the zeros just by looking at the graph first, and then use our algebra to solve. So if we look at this one, we see that the graph goes through at positive 2. Now that is a 0. Let me move this off to the side again. So the 0 is 2, the root. And the factor that matches that would be x minus 2, but it's the 2 that we saw in the graph that goes in. So the graph one, we find that first one. Alright, I'll write down the rest. 1, negative 2, 2, negative 4. Notice it's third cubed, first, and constant, so we're good. And we're going to follow the same exact process using either factoring, square roots, or quadratic formula at the end. So here we go. 1 multiplied by 2, multiplied by 2, multiplied by 2, and I end up with remainder constant x squared. I get x squared plus 2 equals 0. This one is set up really well for square roots because b is missing. This term is a 0. So I'll subtract 2 from both sides. Hopefully remember this from Unit 5. And then I will square root both sides. When I square root that, notice, see there's no perfect square. There's a negative 1, and there's a 2. So I end up with x equals I root 2 plus or minus. So in the braces, you would see 2, you'd see positive I root 2, and you'd see negative I root 2. There you have it. So this process is still the same. We're still going to use one of these three at the end after doing synthetic division. All right, I do have the second one called up here also. There it is. And if we look at this one, we can see that this one doesn't go through exactly here. This one doesn't go through exactly here, but this one goes through at negative 1, 2, 3, 4, 5, negative 5. So negative 5 is the 0, and that's what's going to go into the graph. Okay, third, squared, first, constant, we're good. 1, 13, 51, 55. Let's finish this one out. Remainder, constant, x and x squared. So I end up with x squared plus 8x plus 11 equals 0. Okay, this one is not factorable. That middle term says that we can't do any square roots, so we're going to use the quadratic formula. Let's do b squared minus 4 times a times c. I end up with 64 minus 44, or 20. So we can plug that now into the quadratic formula. Quadratic formula looks like this. Notice that b squared minus 4ac goes underneath the square root sign. I have seen people make that mistake. So the opposite of b, that'd be negative 8 plus or minus the square root of 20 all over 2 times a. That's just 2 times 1, or 2. So the square root of 20 can be split 4. There's no negative. So that's 2 root 5. So I end up with negative 8 plus or minus 2 root 5 all over 2. And now we can simplify. The 2 can go into the 8 and the 2. Negative 4 plus or minus 1 root 5. So our final answers, the braces, are negative 5, negative 4 plus root 5, and negative 4 minus root 5. There you have it. Let's do the last one that we have on here. So far we've had to use square roots. We've used the quadratic formula. Let's see what this last one entails. Okay, I do have this one on the graphing calculator. There it is. Now notice right here it does go through a 1, here it doesn't, and here it does. So we have a choice here. We could pick positive 1, we could pick negative 1. Either one will work. So remember now, I'm going to choose negative 1, because that's what we got right from the graph. And what we should expect then, once we finish the problem, is that positive 1 is also one of the solutions. We should also suggest or expect that the other one is in between 0 and 1. So let's see how this one plays out. X cubed, x squared, x to the first, and a constant. So we're good with the synthetic division. Don't forget to check that. It's an easy thing to check. It makes everything go wrong if you don't. Negative 3, so this is negative 4. 4, so this is 1. Negative 1, this is 0. All right, so good. We get a 0 there. 3x squared minus 4x plus 1 equals 0. Now, again, factoring square roots, QF. QF will always work, just takes a little longer. Factoring, this one is factorable, but it's a tougher factoring problem, so you might not see it right away. So we're going to use a quadratic formula again. We'll do b squared minus 4ac. And I end up with positive 16 minus 12, that's 4. So then using the quadratic formula, opposite of b, opposite of negative 4. So I'm going to write that just as positive 4 here. The opposite of b is positive 4. 4 goes in the square root sign. And then 2 times a is 6. So this ends up being 4 plus or minus 2 over 6. Well, that's two problems. Now we can combine those because they're both integers. 4 plus 2 over 6, that's 6 over 6, or 1. That's exactly what we expected. 4 minus 2 over 6, that's 2 over 6. That's 1/3, between 0 and 1, another thing that we expected. So I will write the answers over here in braces. And there you have it. Again, if you need any more help than what you are given here in the movie, please see your teacher before or after school. Or you can see him during advisement too, that works.